Hey everybody, welcome back to RC with Adam. My name is Adam and welcome to the fourth and final part of our four-part series for 3D printing for beginners. In this video, we are actually going to cover how to print the item. So we have just sliced it in Cura and now we're going to fire up the 3D printer and go through that entire process. Thanks so much for joining me. Let's get started. All right, here is the printer. This is the Creality Ender 3, and this right here is the memory card. You can't really see it very well, but this is the memory card that we got out of the computer. So we put our G-code file on here. We're going to put this right in the little SD card slot for this printer, and we'll go ahead and we can power it on. And you can hear the fans boot up, and this one I haven't really done like upgrades for like fans and stuff, so it's still like pretty loud. It has like the normal drivers and stepper motors and everything. One thing that I have changed is I use a glass print bed. I love printing on glass, and I actually had to I custom made this one out of a mirror. But so if you do it right, it sticks very well. The filament will stick very well. And so what I'm going to do is just wipe off the dust. I really should have like a cover for it, but I'm just going to wipe off the dust with a clean cloth. And the key to getting your filament, or at least PLA, to stick to a plain glass print bed is to wash it with dish soap, like Dawn dish soap, not hand soap, dish soap, and then just wash it with warm water and dish soap, and don't touch it. And don't breathe on it, and don't get any oils on it, because that's really the key is keeping it oil free. And usually you'll get really good prints, and there'll be like a glossy glass finish on the bottom. Looks really good. Now let me give you a little quick tour of the printer here, just so we're all familiar. So here we have our print bed. It is glass. This is actually a mirror, which is why it looks like a mirror. Here we have our little screen and our little dial where we're going to change stuff. Right here, this guy that moves around, this is our print head. That fan that's spinning is to cool the actual heating, the heat sink. So that's not really for the actual printing filament part. This fan right here is what actually comes down here and cools the filament as it comes out, the nozzle. And that right there is the nozzle, that little metal piece sticking out. And you can see we actually have some filament left over from the last print that we did. So we'll just throw that away. Attached to the print head is our Bowden tube. This is an upgrade. It's upgraded so it's a little bit higher temperature and a little bit nicer. It's like a Teflon tubing. And then this goes to our extruder. And we have the extruder motor right here and the extruder gear. Now the gear right here, just to show you, because it's going to be a little hard to show you when I'm actually doing it, but right here you press on this spring and this is going to release the pressure from the from that wheel and the gear right there, and that extruder gear is what actually grips the filament and sends the filament through the Bowden tube to the print head. Okay, you probably knew that already, but anyway, so the print head moves back and forth left and right this way on the x-axis, and then the actual print bed moves forwards and backwards on the y-axis, and then the entire print head assembly and the whole x-axis moves up and down on the what's called the z-axis. And oh, by the way, I actually just made this light rig for my printers, and it's actually works out super great, and it just clamps on. It's really great. Just 12-volt LED lights. It really lights up the place. Now the filament that I'm using is Pro PLA from 3D Fuel, and this should print pretty well, but I have been having a little bit of moisture issues with the filament. This can absorb moisture, and if it does, it won't print very well. But hopefully it will work out for this particular application, and that's why I have it in this plastic bag with this silica beads. And then so what I'm going to do here is I'm going to pull off a section. I want to make sure you can see this. If you can't see this, I apologize, but anyway, I'm going to make sure I don't let the end go so it doesn't get all tangled. And I'm going to use my super sweet filament holder rig here, super high tech. and I'm going to put this in place. So now the filament can rotate on the spool. Super cool. I'm going to take my little side cutters, or little side cutters that you probably got with the 3D printer, and I'm just going to snip off the end here at an angle so that we can have a nice, fresh, clean end on here. And then I'm going to insert this into the Bowden tube past the extruder motor, past the extruder gear, and I'm releasing the tension on the extruder gear by depressing that spring, so that I can just feed this all the way through the tube. If it was clear, you would see it come through here. And once I feel a little bit of resistance, or I mean, once it feels like it's bottomed out, I'm gonna stop pressing on it, because I don't want to have a lot of pressure on the nozzle. So just to show you, cool. So we've got the filament here, and I've run it through here, and what I was doing was depressing this spring to allow me to easily insert the filament. Okay, now I'm going to get into the menu here. I'm going to press on the little scroll knob. I'm going to go down to print from TF, and then right here, here's our file. Swiss motor mount. I'm going to press on that, and now it's going to say bed heating. So it's heating up the bed to that 60 degrees Celsius that we told it to, and then it's going to heat up the nozzle to I believe I set it to 220. So that should work just fine for this. It doesn't actually say what temperature the filament should be heated to on this spool for some reason, but I remember it was like 220 or like 215 to 230, I think was the range. So 220 works out just fine. In case you're wondering, generally speaking, if you print at higher temperatures, it will bond together better and it will be stronger. And if you print at lower temperatures, it may not be as strong, but usually it will. It might look better because it's sort of less like melted. It just kind of depends. It depends a lot on the filament and all that kind of stuff. All right, now since we're just kind of replicating this like we would be doing it in real life, I would just be waiting for this to heat up. So I'd probably go and do something else, and then once I hear the machine start working, I would come back and absolutely watch that first layer, especially if you haven't printed in a while. And watch and make sure that first layer or first couple layers comes down really nicely. Another thing, let's see, that I did not do is I did not level the bed, because as far as I know, the bed is already level. But there's a lot of videos on YouTube that you can watch about how to level your print bed. Generally, what people do is they'll go into their printer settings, and they'll set it to the home position. And then what they'll do is move and disable the stepper motors if they need to, and then they'll move the print head around and have a piece of paper, and they'll kind of like slide the piece of paper under the nozzle, between the nozzle and the print bed, until they get like the same approximately amount of resistance at different points on the print bed. It's a pretty rough way of measuring the print bed levelness, but well, shoot, I mean, you might have a printer that does automatic leveling, because that's becoming more and more common now. But this is a little bit more of a bare bones kind of printer. Another thing, while we're waiting for this to heat up, 3 tools that I like to keep by my printer all the time, whenever I'm doing printing, is these side cutters, these little snippers right here. And these are super great because you might need to, snip the filament, or just snip the filament off of the end of the nozzle, things like that. And then the spatula here for taking off old prints. And also, again, if you you might have filament that's like trailing around the nozzle as it prints and you want to get rid of it, so you use that spatula. And that way you don't have to touch the print bed, because you want to keep your greasy fingers off of the print bed. And then a flashlight. This is really helpful to get a good look at what's going on while you're printing, especially if you don't have one of these kind of overhead light rigs. All right, there it goes. The magic is happening. Now let's get real close here. So we're going to want to watch for a couple things. One thing I'm going to do is I'm actually going to push the filament out a little bit just by hand, just to make sure that it is actually flowing. I'm not really going to like press hard or anything, just to make sure that it's going through there. You don't really have to do that though. It's a little bit more of an advanced maneuver. So now what it's doing is it's doing this little sort of like a little pre-burn. It's sort of, I believe they call it a purge. It's purging out the old filament. So you can see this is what it left. And now what it's doing, it's just doing its thing actually. It's doing its thing, man. But I'm watching this and I'm watching, in fact, let me get the camera off the tripod. So let me show you here. So it's kind of hard to tell because of the mirror surface, especially with this camera. But what I'm looking for is like a consistency in the lines. Again, sorry if I like go out of focus here. So I'm looking for consistency, and I'm definitely checking to make sure that it doesn't get pulled up. I don't want the filament to get pulled up. Let me zoom out, or yeah, let me. And this is usually like a good way of looking at it. Like you kind of have to look at it from the side because you got that big fan and stuff over the print head on the nozzle. There, that's a pretty good shot of it. And this is kind of why you would want that flashlight, so you could actually shine a light under there and see what's going on, which helps quite a bit. So now right now it's printing those circles. And honestly, those circles might make this a little bit trickier to actually stick to the print bed. But so far they seem like they're doing pretty good. It's actually coming out quite nicely. Or so it seems. So it looks like the bed was pretty level. It should be. And it's just gonna do its thing. Now it's actually printing the outside of the model. It's always just so cool to watch. So cool, man. And, you know, I don't really care for this particular application. I don't care that it looks like amazing as long as it's functional. So, you know, you might have a little issue. And I see this little, piece of, there's a little piece of filament there, a little stringy piece of filament. I'm just going to try and snip that off of there. Get that out of the way because it's getting caught in the fan. Come on, little dude. Get out of there. There we go. And there it goes. Okay, so now what it's doing is it's printing the very first layer, the first, well, I guess it'd be the bottom layer. So it's already printed the walls, and it's printed the walls of those circles, or the holes in the bottom of our model. But so now it's printing the bottom layer. You could kind of think of it like the floor of the model. It might be hard to see from the camera angle right there, but what I'm looking for, if you can actually see the model that's being printed, I want to see that the lines are nice and close together, so that we have good adhesion between the lines. And that's going to have to do with the bed being, the bed being level, but then also the right distance from the nozzle so that you get just the right amount of smush in the filament. And then also that's why I turned up the flow rate of the filament on that first layer, or on those first two layers. And so this way, if the bed is not perfectly level, or if the height is not, just right, it will compensate for that with a little bit of extra plastic. So we're sort of giving ourselves a little bit of margin for error. But yeah, this part is really important. So Let's see, can you see that okay? Yeah. So it's kind of hard to see it from the angle, but it's just about done with its first bottom layer. And I believe it's going to do 3 layers, and then it will start doing the infill. And right now it's printing at that 10 millimeters per second, which I think is a good speed, and then it's going to speed up after the first, I think by the 3rd layer it should start speeding up. And now it's working on the 2nd layer. All right, so now you can see it's laying down the infill, and that's why it's doing those zigzag or kind of crisscross patterns. And also it's speeding up. So we're done with our first 2 layers. So now we're going to go back up to, I believe, what was it, 30? Or was it 20? It might have been 25 millimeters per second. Whatever I had it set to, it's faster than the first 2 layers. Now here's a quick tip. There are a lot of different settings that you can change in here. Like you could change the nozzle temperature or the bed temperature as you're printing. So that's cool, like in case you messed it up and you don't want to have to like re-slice it just to change the temperature. So you can change that for like, you know, a single print. And then another thing that you might want to do is the speed is super easy to change. So you just rotate this wheel and it will change the speed right there where it says %. So you can hear the motors change, or at least maybe you can't, but I can. And so the motors will get faster. So we're at 115%, and that's basically like we're at 15% faster than what it was going before. So maybe you realize that you set the speed too high or too slow. You can just adjust that on the fly with this wheel. And so sometimes that's nice because, for example, maybe like this, like it's just a really simple part of the model, and you can go fast and you don't need to worry about detail and stuff. So you could speed that up maybe, I don't know, 20-30%, depending on what it is. And again, I like to print slow most of the time anyway. Or maybe you realize that this part of the model needs to go way slower because there's detail, or maybe there's like overhangs, or whatever the case is. I guess you wouldn't want to print slower with overhangs necessarily, but... Or maybe you're printing something like really tall, and if it gets like jerking around on the print bed, then it will, might get knocked over. So you can actually turn it down to print like way slower. Or maybe like your first layer, you want to print like super slow because you really want it to stick well. So see how slow it's going now? Oh, that's starting to look really good. Look at that. You got those infill lines. And so right now, we could speed this up, actually, because maybe you're like on a deadline or something, and you just want to get that thing done. Although just speeding up the printer is not the best way to actually print faster. If you actually want to print stuff faster, you should really get like a bigger nozzle and kind of change up your whole like workflow and how you slice things as well. But anyway, we could turn up the speed, 110%, let's say, and I think that would work out all right. All right, so we are getting some infill in there now, and we'll come back and check on it once we start to get more of the shape of the actual motor mount, and it's not just that flat piece. All right, we're about 46% done, and you can see we're starting to get some of the edges or the supports, the angled supports are coming up. Looks like we might get a little bit of lifting at the corner, which is not good. It's not good for build plate adhesion if we get that. That is pretty common, or it's more common on large flat surfaces that, well, in this case, like, see, because we're doing all like just straight up layer lines, and so what kind of happens is each line will shrink as it cools, and so that tends to pull at the corners of the print, causing it to come up at the edges. Now, in this case, for this particular application, it shouldn't be a big deal. Like if it's a little bit warped, that's called warping when it comes up at the edges. It's not ideal, but it shouldn't really matter a whole lot if most of it's flat. We'll just have to see how it goes. The worst thing that could happen would be that it like actually warps so much that it pulls off of the print bed. So we'll see how it goes. Another thing to note is that it takes a lot of time to print layers like that. So you can see we just printed mostly like the base layer, which is I think we made that like 2 millimeters, and we're almost halfway done. So it kind of goes to show that if you're printing a lot of surface area, that takes a long time. All right, we'll check back soon. Alrighty, she's looking pretty good. Looking pretty good. Yeah, those are some thick walls right there. We could probably have done with certainly 2 millimeter thick walls. I think would work just fine. But, you know, this will just be a very durable motor mount, hopefully. It looks like the corners might be warping the tiniest little bit, but it doesn't seem to be affecting the rest of the print. And it's kind of hard to tell because of this mirrored finish. So it's like, it's difficult to tell like what's actually the bottom of the print and what's the mirror. But yeah, we'll have to see as far as the overall quality of everything, kind of how it turned out. Because that is another part of the whole printing process, is looking at the finished printed model and then kind of seeing like how it looks and where it could be made better. And you can kind of learn some things about your 3D printer from you know, really looking closely at the model that it prints. Now you might not be able to hear it, but the fan has actually kicked on a little bit louder, so it's working a little bit harder because those layers that it's doing now are going by a lot faster. So like we had it set up in the slicer, the fan is going to increase in speed as the layer time gets shorter. That doesn't really matter, but it's more of a fun fact, and maybe it'll matter down the road. Ooh-wee! Alrighty. Let's see how she turned out. Okay, it looks actually looks a little bit rough. Probably because of the filament. We may have some extra moisture in the filament here. And that moisture is definitely bad for filament, and it definitely leads to poor print quality, which can lead to bad structural integrity. So for something like a motor mount, that might be a big problem. Anyway, to take this off of here, I can just peel up the little skirt piece, and then you can wait until it cools down if you want. Sometimes it's easier to take off after it cools down, but you can see there I just gave it a couple taps, and here we have, and look at that. You see how reflective that is? Oh my gosh, look how shiny that is. That finish. We'll take a closer look at this in just a second. But that's pretty much all there is to it. I can go ahead and push the print bed out of the way. One more really important thing is what I'm going to do is you want to take the filament out when you're done printing, and then you'll want to store your filament in like a airtight container, maybe like a plastic bag or better, to protect it from moisture and that sort of thing. And you definitely don't want to leave it in the Bowden tube. So I waited too long and the print head cooled down the nozzle cooled down too much. So what I'm going to do is I'm going to go to control, I'm going to go to temperature, I'm going to go to nozzle, and I'm just going to turn that up to like probably like 200 or something, just enough to get it hot enough so that it will so that it will start to melt basically, and then I can actually pull that out of there. So now that the nozzle is hot, I'm going to just like I put the filament in there, I'm going to release the pressure on the spring here. I'm going to press that down, and then I am going to, or actually I'm going to press on the spring. Anyway, I'm going to release the pressure on the filament. I'm going to push it forward a little bit to get some filament to run out, and then I'm going to quickly pull it out. So let's push it forward a little bit. This is a very awkward position right here. And then I'm just going to pull the filament all the way out. And sometimes if this is like really tangled or whatever, you might just cut it off and not even bother with it. And we'll do that in this case. Because sometimes it might get chewed up, or it's all tangly, and then that causes friction on the Bowden tube. So sometimes it's not even worth your trouble. And then I'm going to run the filament through the holes in the side of the filament spool to make sure that it doesn't come apart. Oh my gosh. And then we will put it back in its container. I need a better container for my filament. Right now I just use like a 5-gallon bucket with one of those screw top lids, which is good because it's airtight and relatively easy to open up, but it only holds like 3 or maybe 4 filament rolls, and I need 8 of them or something, so I need some more. So we'll put our filament away, and we got to make sure we turn off the, we're going to turn down the nozzle for sure. In fact, what we can actually do is go in here, and then we'll say prepare, and then we'll go to cool down. Cool down. You could also set the nozzle to like 0 degrees, but we'll hit cool down, and that'll cool everything down. I don't like to just power off if the nozzle's hot, because I feel like I don't want the heat to creep into the rest of the assembly, because it's being actively cooled off by that heat break. So anyway, I would just let it cool down to about, I don't know, 50, at least like 50 or 70 degrees Celsius, and then shut it off. Shazam! Here we are. We have our 3D printed, designed, totally original and custom made 3D printed motor mount. So congratulations if you've made it this far. This is fantastic. I mean, this is amazing. We have created this thing, and it's the only one in the world just like it. Unfortunately, I made a little boo-boo. I don't know if you caught this or not, but in Tinkercad, I guess I got confused. I was too busy focusing on trying to show you guys how to do it, that I forgot that I actually needed the front. Basically, I needed this motor wire notch to be on the other side, because the motor wires are supposed to go out like that. So the notch is supposed to be on the left side here instead of the right side. Oh boy. But that happens. That happens. So let's say I did that intentionally just to show you what can happen sometimes. But that's why you don't expect the first one to be perfect. Anyway, let's see how good of a fit this actually is. It looks like it should be a good fit. It looks pretty nice. And actually, right before that, let's take a quick look at the actual quality, how that turned out. The quality. This did not turn out super great. Like it didn't turn out nearly as good as other prints have, and I think a lot of that is due to the filament, not the type of filament, but just the moisture content in the filament, because I have had problems with this particular spool before. Otherwise, though, let's give it a little squish. Seems pretty solid, actually. I mean, I was thinking that maybe 3 millimeters might be overkill, and it probably is, especially for this motor. But it's going to be really durable, though. Like, it would definitely survive a crash for sure. I would say these holes turned out pretty nicely on the bottom. the actual bottom layer, well, I guess it's technically the top layer, but of the bottom plate here, it turned out pretty nicely. I feel like the nozzle probably could have been a little bit closer to the bed, based on, like, if I can kind of see the individual like lines, like if it seems like the layer lines are like separate from each other, that kind of tells me that it probably should have been a little bit closer. And on the bottom here, we do have a nice shiny finish. You can see on the edge right here, see how the finish is a little bit different? See how it changes? That kind of shows that it did pull up from the bed just a little bit during printing, but not a big deal in this case. Also, it's pretty darn smooth, but I like it, again, with I think a sign that the nozzle could have been a little bit closer to the print bed is that I like it when it's like totally smooth, whereas right here I can feel the ridges of the lines. So not a huge deal, and certainly not for an application like this. In fact, honestly, in this application, you're going to be making score marks with a razor blade anyway, so that you can glue the actual motor mount to an airplane. At least that's what I would probably do. Oh, and let's see if a barbecue skewer will actually fit through here. Oh, so close. Okay, you know why? I'll bet it's because, let's see. Let's bust out our calipers. So let's see, this is 4.73 millimeters, roughly, right there. Might be larger in some spots. See, it gets as large as 5.7, this little barbecue skewer. So these holes actually that we made, you can see they got a little bit oval shaped, like the tiniest little bit. So I believe we made them 5 millimeters, but they ended up, when you know, all said and done, we'll see. Well, right there it's about 5.13, but in other spots it's like 4.78. So that's just a little tricky thing, but you know, an easy fix for that is you heat up the plastic and then you push something through it to make the shape, or to make it fit, or you just drill it out. So it's a lot easier to take out plastic than it is to put plastic back in there. While we're at it, let's check these holes as well. So 2.39 roughly, and this is very rough, 2.4. But remember, we said that they should be 2.5. So they did end up a bit smaller. This larger hole here, it looks like 5.8. So almost just about 6. But again, it's very rough measurements here. But anyway, the moral of the story is, depending on your model, you may want to oversize the holes in the actual model. But how cool is that? Like, look at that. This model looks just like the model that we actually designed. Let's try and just see how this motor gets mounted on here. See if we can mount it on here very well. So let's use two of these mounts, or two of these holes. Now, one thing when you're mounting motors, this is just kind of an RC thing. You want to make sure that your screw is not going to go so far that it goes into the windings. In this case, I think it would. So we need to get a shorter screw here. Yeah, so it looks like it fits, because the other concern would be that maybe the holes didn't line up, but it looks like they lined up pretty well. Maybe it might be at a little bit of an angle, but I think if I can loosen both of these, I think that'll work okay. So you can see the actual motor shaft and the retaining clip spinning, and you can see how there's just enough room. We probably could have widened that a little bit more. That probably would have been fine. Also, possibly widening the screw holes, that might have worked as well. But overall, it worked great. Like, look at that. Bam! Especially for a first effort. So thanks for joining me, folks. I hope you enjoyed this. I hope you learned something and hopefully kind of got over the fear of 3D printing Maybe you felt kind of overwhelmed. Hopefully this helped. If it did, let me know. And if you have more questions about 3D printing and anything that we covered here, let me know. Again, check the description below for more information, some good videos, some good 3D printing YouTube channels to check out, because I'm pretty good at it, but it is definitely not my specialty. But I know enough to get by and hopefully share with you and improve your 3D printing as well. Thanks so much for watching, everybody, and I will see you again very soon.
If you enjoyed these videos, you can become an RC with Adam supporter over at ko-fi.com/RCwithAdam. That's Ko-fi.com. What is Ko-fi? Well, it's like Patreon, and you can donate and support your favorite channel, but it's better than Patreon because it's not Patreon.